Think about this for a second. Every time you step onto a plane, you're literally putting your life in the hands of thousands of people you've never met. People in different countries, different time zones, all working together to build something with 3 million parts. And if just one of them fails, well, let's not think about that. But here's what blows my mind. How do you even start building something this insanely complex? Let me show you exactly how it happens, piece by piece, person by person. Why airplane manufacturing is so complex. So here's the thing about modern airplanes. They're not just complicated, they're on a whole different level. We're talking about machines that have to work perfectly in conditions that would destroy almost anything else. Freezing temperatures at 40,000 feet, violent turbulence, the constant stress of taking off and landing thousands of times. And get this, a single commercial jet has over 3 million individual parts, miles of wiring running through it, materials you can't even pronounce, advanced composites, aluminum alloys, titanium. Oh, and here's where it gets really wild. Companies like Boeing and Airbus, they don't build these planes in one place. Different sections get manufactured in different countries. Then they ship everything to one location and basically put together the world's most expensive, most dangerous puzzle. Sound insane? Because it kind of is. Step 1. Building the fuselage. All right, let's start with the body of the plane, the fuselage. Picture this, enormous cylindrical sections like massive metal barrels, each one the size of a small house. Inside these enormous factories, workers are shaping aluminum sheets or carbon fiber composites. Robots drill thousands upon thousands of holes, and I mean thousands, with such precision that we're talking fractions of a millimeter here. But it's not just drilling holes. Workers are installing structural frames, insulation, wiring harnesses that'll eventually power everything from the lights to the entertainment system. They're putting in plumbing systems, all of this before the plane even looks like a plane. And here's the kicker. Each of these fuselage sections can weigh tens of tons. But when they connect them all together, they have to line up perfectly. We're talking tolerances smaller than the width of a human hair. One tiny mistake here, and you've got a multi-million-dollar problem on your hands. Step 2. Wings that carry the entire plane. Now, let's talk about wings, because they're doing way more work than you think. Sure, they provide lift, but they're also storing thousands of gallons of jet fuel. They've got control systems built into them, and they're taking on enormous stress every single time that plane takes off. Inside the wing assembly facilities, you've got teams working on internal ribs and spars, basically the skeleton of the wing. Fuel tanks that have to be sealed by hand, because one leak could be catastrophic. Flaps and control surfaces that let the pilots actually, control the plane. But before any of these wings get bolted onto a fuselage, they test them. And I'm not talking about a gentle little push. They bend these wings upward, sometimes several meters, to simulate the absolute worst turbulence you could encounter. The wings flex like crazy and then spring back into place. Because if they can't handle that test, they're definitely not handling your flight through a thunderstorm. Step 3. Jet engines, a factory of their own. Okay, jet engines deserve their own moment here. These things are so ridiculously complex that they're not even built in the same factory as the rest of the plane. They get their own specialized facilities, their own teams of engineers. Inside each engine, thousands of precision machine parts, turbine blades that spin faster than the speed of sound, combustion chambers where temperatures get hotter than molten lava. Let that sink in for a second. Hotter than lava. And before any engine gets shipped to the final assembly line, it gets tested at full power, full throttle. Because, and I cannot stress this enough, failure is not an option once you're 35,000 feet in the air. Step 4, final assembly, where everything comes together.
Now, we get to the moment where it all comes together. Picture a hangar so big you could fit entire neighborhoods inside, and in the middle of it, sections of airplane being wheeled in from all over the world. First, they join the fuselage sections, then they attach the wings. And remember, these wings weigh as much as several cars. Engines get mounted, landing gear gets installed, and this isn't robots doing all the work. This is thousands of people, engineers, electricians, inspectors, all moving in these perfectly coordinated teams. It's like watching a massive, high-stakes dance. Because here's the reality. One mistake at this stage, it can delay delivery by months, cost millions of dollars, and potentially put lives at risk down the line. So yeah, no pressure. Step 5. Testing everything. You'd think once the plane's done, it's done, right? Not even close. Before a single passenger ever steps on board, every system gets tested. Hydraulics, electronics, flight controls. They pressurize the cabin, test every emergency system, check and double-check and triple-check. And then comes the moment of truth, the first test flight. Specially trained test pilots take this brand new aircraft up into the sky and push it through its paces. They're not just cruising around, they're testing everything that could possibly go wrong. Only after it passes all those tests, only then does it get approved for airlines to actually use with paying passengers. The human scale behind one airplane. Let's zoom out for a second. By the time one commercial airplane gets delivered to an airline, thousands of workers have touched it. Parts have literally traveled around the entire world. Years, sometimes decades of planning and coordination have gone into it. And while you're sitting here watching this video, there are factories right now, at this very moment, building the next one, and the one after that, and the one after that. It never stops. So the next time you're on a plane, sitting by that window, watching the wing flex and bend as you hit some turbulence, I want you to remember something. That wing was shaped by human hands, tested by human ingenuity, installed by teams working around the clock, all so you could sit there, 40,000 feet above the Earth, and safely fly across the world. Pretty incredible when you think about it, right?
The global supply chain operates in real time, a constant flow of critical components ensuring seamless production across continents.